I have explained before about the Derby Rail Technical Centre in several of my videos, but I haven't really delved that much in depth about it. I intend to correct that mistake today. The Derby Technical Centre was probably one of the most unique assets British Rail had, and it contained a vast array of rolling stock. The site itself had seen over 100 years of railway use. Before the railway, the land was owned by a local man called Geoffrey Etches. He was famous not for railways, but for cheese, and erected a warehouse and recreational ground he called Etches Park. When the railways came knocking, the Midland Railway was looking for land to put a carriage shed, and the park fitted the bill nicely. Etches Park was sold quickly, and a new painting shed and carriage works were built, including over 2,000 foot of track. The remaining land was used to link London Road Junction with Spondon Junction on the old Midland Counties line. All of this were ready and open by 1864. Over time, the Midland Railway moved its Way and Works department to Derby and facilitated a new store built on surplus land from the sale. The store would include a grease and oil store and equipment room, so the workers would be able to store equipment safely. There was also a smaller works so they could repair smaller equipment. The Way and Works were responsible for the majority of Midland's infrastructure, right down to the telegraph poles and ensuring the stations and lines were looking their best. In 1910, the works got an upgrade with a new shed and rail access, and a further 2 grease and oil stores were approved. Experiments on locomotives were done as early as the locomotives were able to grace the railways. But Samuel Hall's smokebox consuming apparatus in 1841 seemed to be the starting point in Derby's story. Parliament were under pressure to get the smog and smut from burning coal under control, and the railways were forced to follow suit. They burnt coke, which gave off less smoke in general, but it was very expensive next to coal. Hall wanted the engines to run on coal, but they had to meet the smoke requirements. The experiments led to the inclusion of a brick arch in the firebox, but it was the Midland Railway's Matthew Kirtley that solved the issue. He combined the brick arch with a firebox door deflector plate and steam blower, and this is a system pretty much unchanged throughout the ages. Another famous change that Derby oversaw was the changes to the smoke box. Apart from the firebox, the smoke box is one of the hottest parts of the engine, and the hot gases regularly took the engine out of service. Robert Stevenson came to Derby to research on how to solve this problem, and was able to experiment with different metals at different temperatures on a regulated environment. The experiments led him to make improvements to the boiler. As the gases had further to travel, they were cooled to a more palatable level. The versatility of the area was astounding, and soon it wasn't just locomotive improvements that were being trialled. Rails, infrastructure, signalling, and even the composition of metals were being tested at the site. By 1910, there were several labs around the site that would test everything from metal wearing pressure to the hardiness of fabric used to make seating. In 1923, following the grouping, the newly formed LMS wanted to centralise the facility under one roof. The Work Surplus and Facilities Store was a perfect location. In 1933, the LMS set up the Scientific Research Department. New buildings were constructed with over 5,600 square foot of working space and over 2 floors and an adjoining shop covering 3,500 square foot of space in its own right. It was made for function, not form. It held an imposing shadow on the landscape, but its work inside was of crucial importance. Nothing, not even the paint for the bridges, would be cleared for use by the LMS without it passing through the research centre. In 1936, in the midst of the speed race, a wind tunnel was erected to test the effectiveness of different engine profiles aerodynamically. The experiments led to the improvements of some engines, including the effectiveness of smoke deflectors. In 1948, the Big Four came under government control under the new name British Railways, and for a time the research team collaborated with the other facilities the Big Four previously used. But in 1961, it was decided to merge these facilities into one, and Derby was chosen to be its home. A new site was chosen opposite the old facility, and work began on a new research centre. It would be called the Derby Technical Centre. The centre would oversee the running of all civil engineering and research. Computers would be employed with bespoke programs, and for the first time electrical division was brought in, all dealing with telecommunications and signalling. A new building called Derwent House was also built, ready to house the British Rail Engineering offices. British Rail Engineering was the main powerhouse behind the building and maintenance of the workshops that supplied the engines and rolling stock. The Central Purchasing House was also located there, who too oversaw the purchasing of all consumables from lorries to uniforms. Other buildings and facilities would soon set to follow. Plastics development units, rolling stock development units, new weighbridges and cranes. If it needed to be researched, then Derby was the place to be. While the 800 or so staff that were now employed at Derby were kept busy with smaller projects, there were several projects that the centre were famous for rolling out. The computer-assisted timetable was one of them. Let's say I wanted to get from Skipton to Aberystwyth. There's no obvious direct route, so I have to change at one of the other larger stations such as Leeds. Then from Leeds, change again. Before the system was introduced, clerks would have to have individual timetables and plot the route by hand. If the clerk was on the phone, this was highly inefficient. The system fed information from every single station, and the clerk would simply need to enter the start and final destination. The plot would then be calculated with a few seconds rather than mere minutes. It's the very same software that is in use on many apps on all of our smartphones. Another innovation was automatic route setting. Prior to this, setting a route would always lie with the signalman, and with it, they were prone to error. Many accidents have been caused by setting the wrong route, and each wrong path given must be logged in the book regardless of whether it was taken or not. The automatic route setting was designed to plot trains with the best route and set them without the signalman being able to calculate it. It is still in operation today. But one of the most famous innovations was the AMU, or Advanced Multiple Unit. This was the precursor to the APT and would be designed to replace the ageing diesel fleet. To test these engines in a practical environment, a test track near Derby was used and was connected to the main line via Melton Broadbury Junction. The 13 miles of track were perfect for the APT to be put to the test. The track itself was a mix of different sleeper types and continuous welded tracks. The track had several tunnels, and there was a workshop nearby to help with any repairs or adjustments. There was also a secondary test track at Mickleover, which was just as challenging. The test centre, despite British Rail's money woes, amazingly survived for over 30 years and was the beating heart of British Rail's innovation. But the privatisation plans put the centre's future into doubt. In 1994, private railway companies began to take over parts of the centre. Eventually, like a dimming flame, the railway's research influence on the park diminished, making way for private-let and consultancy firms. The park was renamed as the RTC Business Park. The only part used for research is the moving model aerodynamic facility. But there is still a railway influence still at the centre. Parts of the centre are still being used by Loram for its care, storage and maintenance of the engines. The engines looked after there include many notable favourites, including the Class 67s and of course the network measurement trains. It's still a very clear and notable hive of railway activity, very different from the one envisioned, but still very useful to the railway today. And who knows, with the introduction of the nationalisation scheme, maybe this place will be revived as the railway's own personal laboratory.